So in 3.3, we have what's called the addition rule, or sometimes it's referred to as the OR rule. So again, since we're dealing with probability, we still have this basic formula. The probability of event E happening is going to equal the number of outcomes in event E divided by the total outcomes in the sample space. Now, when it comes to the addition rule, this is our OR thing. So if we have the probability of A or B, this is where we get into what's called mutually exclusive and not mutually exclusive. If they're not mutually exclusive, I'm saying if they are mutually exclusive, then all you got to do is add the probability of A and the probability of B. So we use this if they have no overlap. There's nothing in common. That's where these Venn diagrams came into play. The other one we had was the probability of A or B. This one happens is when they're not mutually exclusive. So this is going to be the probability of A plus the probability of B. And then you're going to subtract out the intersection. So the probability of A and B happening. So what they have in common. So we remove that. So we have this is mutually exclusive, which means they have nothing in common. And then this is going to be not mutually exclusive. So that means there's going to be an overlap. So let's look at these questions here. Number 11. A standard deck of cards contains 52 cards. One card is selected from the deck. Compute the probability of randomly selecting a club or a heart. So notice how these would be mutually exclusive because you can't be a club and a heart. So these would not have anything in common. So the way we do this is the probability of A or B happening. So the probability of a club happening, there's going to be 13 clubs in 52 cards. Or, so we add the heart, there's 13 hearts also out of 52. So in other words, we have 26 choices out of 52. So in other words, half of the deck is club or heart. So that's a 50% chance, or 0.50. 0.500 if you go 3 decimal places. So there's a 50% chance of making that happen. That should make sense in that probability. Again, you could also do all that on a calculator. So the next one says, compute the probability of randomly selecting a club or a heart or a diamond. So this is kind of saying like probability of A or B or C happening. Now this is not too complicated since these are mutually exclusive. You can't be a club, heart, and diamond. So these are all mutually exclusive events. So to get a heart, to get a club, you have a 13 out of a 52 chance. And you want to add to that, the chances of getting a heart would also be 13 out of 52. And the chances of getting a diamond would also be this 13 out of this 52. So in other words, 26 plus 13, you have a 39 out of a 52. So 39 of the 52 cards are in your favor. So if we do the 39 divided by the 52, that's going to give us this 0.75. So 75% chance of that happening. Okay, since there's only 4 suits in the deck, the spade's the only thing left out. So you have a 75% chance of that happening. So notice how you probably don't even need this formula here. You probably could use your logic there to get those as well. So C says, compute the probability of randomly selecting a 4 or a spade. So notice how 4 or spade, notice how there is an overlap here because there does exist a 4 that's also a spade. So we have to remove that out of this problem. So this is not a mutually exclusive event. So this is going to be the probability of A or B. But what you have is you want to find the probability of getting a 4. You want to find the probability of getting a spade. But you want to remove the probability of the 4 that is a spade. So we have to remove that out, that overlap. So that's going to be not mutually exclusive. So we have to remove the overlap. So the probability of 4, there's 4 fours in a deck, and there's 52 cards in a deck. So it's a 4 out of 52. The probability of getting a spade, well, there's 13 spades out of 52 cards. And then how many fours that are spades? That's going to be there's going to be a 1-4 that 4 spades out of that 52. So you have a 152 chance of that gets removed. So this is based on fractions since the denominators are the same. So that's what, 17 minus 1 would be like 16 out of 52. I did that math correctly. So if we go ahead and just divide 16 by 52, that'll give us this number here. So it's a 0.308 if I carry it out to 3 decimal places. So 0.30. So you have around a 30% chance, 30.8% chance of getting a 4 or a spade. So that's 30.8% chance happening. So that's how we have to watch out for the overlap, and we have to subtract that out.